Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals involving greatest integer function, right? So here we have this problem, that is we have to find the integral from -1 to 0, and we have x square over greatest integer of 1 plus x square, right? So here we see that the integrand involves the greatest integer function, right? So this problem is a very important problem for the beginners. So let us start, and let us first call this integral as I, right? So here we'll solve this integral by method of substitution, right? So let us assume here t is equal to 1 plus x square, right? So we are assuming t is equal to 1 plus x square. So therefore x square is equal to t minus 1, and x can be written as square root of t minus 1, right? Okay, so now let us differentiate x with respect to t. So the derivative of square root of t minus 1 is equal to 1 over 2 times square root of t minus 1, and by chain rule the derivative of t is 1 and the derivative of 1 is 0, right? So we can now write 1 over 2 times square root of t minus 1, right? So dx over dt is equal to 1 over 2 times square root of t minus 1. So therefore dx is equal to dt over 2 times square root of t minus 1, right? So now here we see that the limits of integration vary from -1 to 0. So let us change the limits accordingly. So when x is equal to -1, then the value of t can be calculated from this relation, right? So t is 1 plus -1 square. So this is 1 plus 1, that is 2. And when x is equal to 0, then the value of t is 1 plus 0 square, that is 1 plus 0 is equal to 1. So we see that when x varies from -1 to 0, t varies from 2 to 1, right? So now let us write this integral I in terms of t. So now we have the limits of integration from 2 to 1, and for x square we can write from here t minus 1, and in the denominator we have greatest integer of 1 plus x square. So 1 plus x square is replaced by t here. So we have t, and for dx we can now write dt over 2 times square root of t minus 1, right? Okay, so now here we see that the value of t in this integral varies from 2 to 1, right? It implies that t lies between 1 and 2, right? So when t lies between 1 and 2, then from the definition of greatest integer function, the value of greatest integer of t should be equal to 1, right? So here the greatest integer of t can now be replaced by 1. So we have 2 to 1. Here we have t minus 1, and here we will now have 1, and we have dt over 2 times square root of t minus 1. And now we can take half outside the integral. So we have half 2 to 1, and we have t minus 1 over square root of t minus 1, right? So now we have to evaluate this integral. So now we can write this integral I as a half, and we have 2 to 1, and here we see that we have t minus 1 raised to 1, and here we have square root of t minus 1. So we can now write this square root of t minus 1 as t minus 1 raised to half. So we can now write t minus 1 minus half, right? And here we have dt, so this is now half, and we have 2 to 1, this is t minus 1, and 1 minus half is half, right? Okay, so now we have this integral, and we can now solve this integral again by method of substitution, or we can also directly write its integral, but here we'll prefer the method of substitution. So let us substitute u is equal to t minus 1, right? So du is du over dt is equal to 1. The derivative of t with respect to t is 1. The derivative of 1 is 0. So now we have du is equal to dt, right? And here t varies from 2 to 1. So when t is 2, the value of u is 2 minus 1, that is 1. And when t is 1, the value of u is 1 minus 1, that is 0, right? So now we can write this integral I as half, and we have the limits of integration from 1 to 0, and here we have u raised to half, and here we have du, right? So now the integral of u raised to half is u raised to half plus 1, and here we have half plus 1, and the limits of integration are from 1 to 0, right? So here we have used the result, that is the integral of x raised to n dx is x raised to n plus 1 over n plus 1, provided n is not equal to minus 1, right? So here the value of n is half, so we have got this expression, right? So now I is equal to half, and we have u raised to 3 over 2 over 3 over 2, and the limits of integration are from 1 to 0. So now we can take this 2 to the numerator, so we have half multiplied 2 over 3, and we have u raised to 3 over 2, 1 to 0, and this 2 and this 2 get cancelled. We have 1 over 3, and now we can substitute the limits here, and we'll take the difference. So we have 0 raised to 3 over 2 minus 1 raised to 3 over 2. So this is 1 over 3, this is 0, and this is equal to 1. So now we have minus 1 over 3, right? So the value of 1 raised to 3 over 2 is 1. So now the value of this integral is equal to minus 1 over 3, right? So this is how we can solve this integral.